So what I'm going to do today is I want to talk about what the heck this course is. What is microeconomics? What are you going to be learning in this course? And just sort of set us up for the semester. Okay, so basically, microeconomics is all about scarcity. It's all about how individuals and firms make decisions given that we live in a world of scarcity. Scarcity is key because basically what we're going to learn about this semester in various shapes and forms is a lot of different types of constrained optimization. We're going to learn a lot about different ways that individuals make choices in a world of scarcity. Okay?
Quickly summarizing what this course is about, it's about the math that computer scientists almost all need regularly and which you're not likely to have come across in your standard calculus classes. You may have seen some of this stuff in high school. For example, in calculus courses, people talk about functions on the real numbers, and sometimes they'll talk about functions on the complex numbers. But computer scientists are usually dealing with much more abstract functions on data types and even functions on functions. And I wonder how many of you, if I asked you to define abstractly what a function was, could give that definition. In a couple of weeks in this class, you'll be able to do that with facility.
Thanking everybody for coming back. I think there'll be a few people coming in late, still hitting the send button on the papers. I want to thank everybody that submitted papers before the 9th class because I actually had a chance to read those 26. Since there are actually officially 84 or 85 people registered for this class, I'm intrigued to see if 59 papers came in a minute ago. Human nature being human nature, these are just the statistics on this class. As those of you who may have seen, I chose that part of the experience here is actually eyes on, meaning my eyes on your papers and giving comments. If you don't want the comments, you just want to grade, you can always give me a heads up and send me an email, and I'll take less time.
Thank you all for uploading all your stuff last night. We do watch everything, just so you know, and it's really, really helpful for us. So I really appreciate you guys doing that. I thought we'd start off today by doing just a quick exercise where you say the point of your video in 1 to 2 sentences. And I was thinking about this last night because it's actually a really nuanced thing, understanding the difference between what the point of your video is and what your video does. I was trying to think of a good way to explain it last night and this morning. And I think that might be the best way for me to understand it. And that's why I gave that example of the snot video, right? Because the point of the video that I made about snot wasn't to explain what snot is. That's what my video does.
This is the 9th session, but we have a little bit from the last session to finish. I want to say just a little more about the autonomic nervous system. And this is where we ended last time. And let's go back to when we talked about the early development of the spinal cord and the formation of the sympathetic ganglia. This was the picture we used. You see the thickening of the neural plate there, formation of the neural groove, and then the neural tube, formation of the dorsal root ganglia. But then from those neural crest cells, we also have the formation. Some of these cells migrate and form the paravertebral ganglia, a series of interconnected ganglia along the side, just in front and to the side of the spinal cord. Okay, they're outside the vertebrae, in between the paravertebral ganglia and the neural tube there, the spinal vertebrae.
This course is going to be about trade-offs. Given scarce resources, how do individuals and firms trade off different alternatives to make themselves as well off as possible? That's why economics is called the dismal science. Okay, economics is called the dismal science because we are not about everyone can have everything. We're always people saying, no, you can't have everything. You have to make a trade-off. Okay, you have to give up X to get Y. And that's why people don't like us. Okay, because that's what we're called the dismal science, because we're always pointing out the trade-offs that people face.
It's doubtful if you really understand something if you can't explain why it's true. And that's what proofs are about in mathematics and in computer science. So we're going to be talking about proofs of lots of things that we're trying to understand. And in particular, we're going to look at a proof technique now called proof by contradiction, which is probably so familiar that you never noticed you were using it. And now we're going to call explicit attention to it and think about it. So let's do an example first to see what's going on.
I want to compliment everybody. They're good. I mean, there's a good engagement, a good dialogue. You will see occasionally that I don't give you everything you want back, but a couple observations. It's really an opportunity on any topic you want to choose in the second half of the semester up to maybe the 23rd class. Please, if 70 of you handed in on the 23rd class, that is your right, that is your option. It's just going to be harder on Sabrina, Talina, and me to grade. But it's to use critical reasoning about that week's topic. So let me just mention 2 or 3 things some of you did. I'm not going to be harsh about it, but some of you did that's not what I'm looking for.
Today we are having a table read, which basically means that we're all going to go around and read the scripts where you have them standing, as of now. The way it'll work is that, say Siri goes first. She would read the script aloud. We would all keep our laptops closed for the first reading, so just listen to her script as it flows. And then the second time she reads it, we'll follow along on her script on Annotation Studio and make notes in real time. And then afterwards we'll talk about any feedback that we have for her. And then we'll just go around the class. Do you want to say anything before we start?
Now, for the parasympathetic, it's quite different in the nature of the innervation. Okay, because now the preganglionic motor neurons are up in the brain. They're in the dorsal motor nucleus of the vagus nerve. They're in salivatory nuclei, very tiny nuclei in the upper hindbrain, the rostral hindbrain, or in a little part of the third nerve nucleus, the Eydinger Westphal nucleus, the nucleus that controls the pupils. Okay, so now, in the case of the parasympathetic system, the postsynaptic cell here, it gets the synapses from the brain, the axon coming from the brain. It's always near the end organ. So for the eye, it's a ganglion behind the eye. Okay, and the axons go to the iris.
All engineering is really constrained optimization. How do you take the resource you're given and do the best job building something? And that's really what microeconomics is. Just like 270 is not a dismal contest, microeconomics is not, to me, a dismal science. You can think of this course like 270, but instead of building robots, we're running people's lives. Okay? That's kind of the way I like to think about this course. Instead of trying to decide how we can build something, move a ping pong ball across a table, we're trying to decide how people make the decisions to consume and firms make the decisions to produce. That's basically what's going to go on in this class.
If an assertion implies something false, then the assertion itself must be false. That's what's going on here. If you're reasoning step by step, and at every step your reasoning is good, which means that if you had something true and then you reached a conclusion from it in one step, the conclusion that you reached was also true, then if you start off with some assumption and you keep proving things step by step in a way that preserves truth, and you arrive at something false, it's inevitable that what you started with must have been false, or else the thing you finished with would have been true. Okay, let's look at a real example of this, an amazing fact that was known thousands of years ago to the ancient Greeks, which is that the square root of 2 is irrational. Now let's remember that a rational number is a fraction. A rational number is a quotient of integers.
Now, just as a way of background, I've spent 39 years in finance, so this is just my chance to take 80 minutes to talk about finance with all of you. We did have readings. It will tie into it. So, overview, we're going to talk a little bit about the readings, of course, as we always do. 3 slices of finance for a moment. Finance and financial institutions. What is a financial institution? What does that word mean, and how do we think about it? Finance and regulation, finance and technology. So 3 quick slices of finance. What is credit? What's capital markets? Again, a broad sort of Gensler's view of it maybe, but still I think it's grounded in academic literature.
I think everyone's in a really good spot as far as ideas go. Like the topics of your videos are actually very, very fascinating, so that's a really good space to be in. I think that the common sort of room for improvement that people have right now is connecting specific examples to the bigger picture. And I think that you get that in your head, but making it a little more explicit in your script is where where your focus should be on next. And I tried to give some of that feedback online, and maybe today I can explain some more of the comments if you didn't understand them as well. But connecting sort of the facts that make up a tutorial video into a bigger picture, like this is why you should care, is a very tricky thing to do. But hopefully today, with the feedback of everyone in class, you can have a better sense of how to do it.
So let's take a look at how that fluid is made. These are the questions we want to answer. What cells make the cerebrospinal fluid? Originally it was just the fluid, the embryonic fluid, and then the neural tube closed, so now it's all inside. So the only way you're going to replenish that fluid now is if you have cells secreting it. But you have to keep in mind the cerebrospinal fluid isn't just in the ventricles, it's also outside the brain. How does it get out? Okay, it's around the outside the pia. Okay? We say it's in the subarachnoid space surrounding the brain. We want to see what that means and how it gets there. And then a term for part of the ventricles, the aqueduct of Sylvius, will define that too.
Now, what we're going to do in this class is focus on two types of actors in the economy: consumers and producers. Consumers and producers, okay? And we are going to build models of how consumers and producers behave. Now, technically, a model is going to be a description of any relationship between two or more economic variables. Okay? That's a model, description of any relationship between two or more economic variables.
So now we begin on 4 classes on number theory. The purpose of taking it up now is that we're still practicing proofs, and number theory is a nice self-contained elementary subject, as we'll treat it, which has some quite elegant proofs and illustrates contradiction and other structures that we've learned about. A little bit of induction and definitely some applications of the well-ordering principle. The ultimate punchline of the whole unit is to understand the RSA crypto system and how it works. Along the way, we will today actually establish one of those mother's milk facts that we all take for granted about unique factorization of integers into primes. But in fact, that's a theorem that merits some proof. As an example, in the homework shows where we exhibited a system of numbers which didn't factor uniquely.
Providing liquidity. I'm agreeing with all of them. You should have written my slides. I should revise the slides. So I say it's basically investments, basically the store of value, and credit, in essence, borrowing value. Remember what money is. I know Ross is looking at me like, It's the two sides of, we have this social concept of money that goes back thousands of years, and at some point in time, what if I want to store the value or borrow the value? It's the two sides of the It's, again, centered on a social construct. And thus, financial intermediaries sit right at the neck of the hourglass and transform risk as well. It could be a bank that's transforming risk, short-term deposits, or then loaned out long. So right at the center of the banking system, the commercial banking system,
What do a cell phone, a river, and a cancer cell have in common? The answer is fractals. Fractals in mathematics are never-ending patterns. Scientists can program these infinite patterns by repeating a simple mathematical process over and over. So if you zoom in, you'll see the same shape again and again and again. And here I would show an animation of that on a computer. Similarly, a tree grows by repetitive branching. Just like our fractal, a tree extends its branches, one smaller than the other, but similar. A tree can't grow as far and precisely as a truly mathematical fractal, but we can still study nature in terms of fractals. In fact, so many things in nature have these pattern properties, and show animation of all those things. It sometimes feels like the world itself is one giant fractal.
We know about the origin of the term rhombin cephalon because of this rhombic shape. We've mentioned that before. But there's another question I want to ask about that, because this landmark, the OBEX, is commonly used in neuroanatomy. Radiologists use it too. And if you're in medical school and you're learning a little bit about radiology of the brain, you'll learn this. This is what they mean by the OBEX. This point right here at the caudal end of that rhombic shape. Okay, where the widened roof plate is no longer widened. Okay, that is what the OBEX is. It's an important area because it's an area where there's a weakening of the blood-brain barrier, and it's very important getting rid of toxins, can elicit vomiting and so forth when there's something bad in the blood.
The trick with economics, and the reason many of you will be frustrated during the semester, is unlike modeling the relationship between, say, energy and mass, these models are never precise. They are never accurate to the 10th decimal, okay? This is not a precise scientific relationship we'll be modeling. We'll be making a number of simplifying assumptions that allow us to capture the main tendencies in the data, that allow us to capture the main insights into how individuals make consumption decisions and how firms make production decisions. But it's not going to be as clean and precise as the kind of proofs you're going to be doing in some of your other classes in freshman and sophomore year.
So let's begin by stating the rules of the game. We're going to assume all of the usual algebraic rules for addition and multiplication and subtraction. So you may know some of these rules have names, like the first equality is called distributivity of multiplication over plus, times over plus, and then the second rule here is called commutativity of multiplication, and here are some more familiar rules. This is called associativity of multiplication. This is called the additive identity. A minus A is 0, or actually additive inverse. 0 is the additive identity, and minus A is the inverse of A. A plus 0 equals A is the definition of 0 being an additive identity. A plus 1 is greater than A.
The center thing about investment banks is about, still has underwriting, but it's usually related to market-based rather than using their own balance sheet, but market-based securities and brokerage. Insurance is a risk transformation. I need to be covered if I get into an auto accident. I need to be covered if my house burns down. So thus, I buy that insurance. Classic forms of insurance. And then all forms of asset management and collective investment vehicles. I make it as two different buckets because a collective investment vehicle is when you actually put something into a shared balance sheet, like a mutual fund. Asset managers are really just getting paid a fee, but the two overlap.
Rivers of the planet flow like the blood vessels in our bodies. Lightning bolts become electrifying rivers of the sky. And just look at this honey. Show fractal honey. Here's something even wackier, a brain fractal-shaped forest. One way to explain this abundance of patterns is the fact that nature is just great at reusing efficient mechanisms. How and why that happens, we can't really tell. But although the existence of fractals remains a mystery, mathematicians have found a way to study the wacky structures. Clouds are not spheres and bark is not smooth, but with fractal geometry we can mathematically explore them. In the 1970s, a mathematician named Benoit Mandelbrot was hired to investigate noise in telephone lines. Now Mandelbrot loved connecting images with numbers, so he immediately graphed the data he collected.
If I asked you in just a very few words, what is the difference between hindbrain and spinal cord, what would you say? I mean, what are the secondary sensory neurons of the hindbrain? What are the hindbrain senses? Like auditory, vestibular. They form clumps of cells, nuclei. That's not true in the spinal cord. Okay? In the spinal cell, there's a continuous column of secondary sensory cells, but that's probably because the inputs don't come in through a single nerve. They come in through multiple nerves. The dorsal roots of those nerves have a distribution that always overlaps with the adjoining root. So there's a continuous group of secondary sensory neurons.
So basically, prices will determine what gets produced, how it's produced, and who gets the goods that are produced. Okay? Of course, this is a very, very simplified example, as you can already tell. There are lots of cases where prices don't decide these things. So my favorite example is the fact that there are lines for hours to get tickets to see a Lady Gaga concert. Okay? Now, if it's really true that prices determine everything, we shouldn't see any lines. It should just be that those who are willing to pay the most to see Lady Gaga should, those who want to see the most to get a Lady Gaga should get the tickets. Those who aren't willing to pay shouldn't get the tickets. Why should there be a line? Not to mention the fact that people shouldn't be willing to pay anything, but that's a different issue. That's a taste issue. We'll come to taste later.
Well, the division theorem says that if I divide A by B, that means if I take the quotient times B plus the remainder, I get A. And in fact, there's a unique quotient of A divided by B, and there's a unique remainder of A divided by B, where the remainder, what makes it unique is the remainder is constrained to be in the interval greater than or equal to 0 and less than the divisor B. So we're going to take this fact for granted too. Proving it is not worth thinking about too hard, because it's one of those facts that's so elementary that it's hard to think of other things that would more legitimately prove it. I'm sure it could be proved by induction, but I haven't really thought that through. Okay.
The secondary markets have much more volume than the primary markets. The ratio is not the same market to market. Some markets, there's a lot of profitability. If you're thinking about finance and where you can make your own businesses and money, there's a lot of juice in the primary market. There's a lot of activity and very illiquid or not tradable secondary markets. Whereas like equity markets, highly liquid equity markets, all the actions in the secondary market. Apple, I don't think has done any primary issuance in well over a decade, maybe a couple of decades in the equity markets. But certainly the secondary market for Apple stock is quite robust. Whereas there's some things that it's only about the primary market.
So the reason why George and I don't have people look at the text the first time around is because when you're watching the video, ultimately you're not reading it with the script in front of you. And you'll notice that like there may be moments where you tune out when you don't have a script in front of you following along, which is going to be the experience that a viewer is going to have. And I know that that's very difficult to do because we don't have the visuals, which is why we also do it again with the script. But the first time is more to just like experience it as close to an experience as the viewer would have of the video, because they're not going to be following along with notes.
What's the critical role of the hindbrain in feeding behavior? We can't eat without the spine brain. Swallowing, it's a very complex reflex. It's a fixed action pattern. We call it a reflex, but it's actually a fixed action pattern that can be, the probability of triggering it goes way up with certain stimuli. Stimuli behind in the back of the tongue. Okay, but we do swallow automatically and periodically all the time. Keep our throats lubricated. But what else we need? We need the hindbrain for feeding. Control of the jaw. Jaw opening, jaw closing. Okay? There's a special nucleus. It's part of the fifth nerve. That's not just sensory. It's not just the trigeminal nerve. Okay, it's also the masticatory nerve, the motor component of the fifth cranial nerve.
I offer my, you know, my alarm clock or whatever on eBay, okay? And then people bid on that, and whoever values that the most, that rare John Gruber alarm clock the most, they get it, okay? So it's a perfect textbook example, okay? And basically, because on eBay, the price is used, or now with also StubHub and concert tickets, the price is used to allocate the good to the person who wants it the most, okay? Now, a recent example of an auction eBay got a lot of attention, not so recent anymore, a couple years ago. Someone tried to auction their kidney on eBay, okay? Someone offered their kidney for auction on eBay. They said, I have 2 kidneys, I only need 1, so I'm gonna auction my kidney. You pay for me to fly to wherever you need my kidney, and the operation, they take it, I'm gonna give it to you, and that's the way it goes.
A key relation that we're going to be looking at today is the relation of divisibility between integers. So by the way, all of the variables for the next week or so are going to be understood to range over the integers. So when I say number, I mean integer. When I talk about variables A and C and K, I mean that they're taking integer values. So I'm going to define C divides A using this vertical bar notation. It's read as divide. C divides A. If and only if A is equal to K times C for some K. And there are a variety of synonyms for A divides B, like A is A divides C. C divides A is to say that A is a multiple of C, and C is a divisor of A. Okay, let's just practice this. So 5 divides 15, well, because 15 is 3 times 5. A number n divides 0. Every number n divides 0. Even 0 divides 0, because 0 is equal to 0 times n. So 0 is a multiple of every number.
I know you're tired and you're quiet, but if I were to give you an exam, one of the 20 questions I would give you on vocabulary is ledgers, because ledgers matter to blockchain and blockchain matters to ledgers. I'm not saying that there is no use for blockchain technology absent ledgers, but I'm hard pressed to think, you know, of a really good use case within finance, at least, unless you have some ledger, some recordation of things of value. If you're keeping a record of things of value, then the immutable nature of blockchain becomes more relevant. If it's not things of value, I'm just saying I'm a little bit harder pressed to say why you need the complexity of this database structure. You could use other database structures to keep it. Even though Stuart Haber has that wonderful blockchain that's published in the New York Times for notaries.
So how about for this next part, let's all go to Annotation Studio and look at the fractals document. Sorry, my internet's
I know, mine's slow too.
slow.
I'm here.
Would you guys find it more helpful if for the second time through, everyone got to read through the script at their own pace and then offered feedback? Would you rather do it that way? Yeah. Yes? Okay. Then how about everyone take a look through Yulia's script take a couple minutes to do that. And if you have feedback while you're reading through, go ahead and make notes, and then we'll talk about it afterwards.
Now here's the other thing they described that was so important. Here is one neuron. This entire picture is of one neuron. It goes from the cervical spinal cord to the rostral end of the thalamus, diencephalon. And this is one thick section where they could follow the axon from this cell in the hindbrain. It was a lower pontine cell or upper medulla oblongata. Here's the axon, and it bifurcates. Here's the descending branch where it distributes various collaterals. And look at the ascending branch. Collaterals in the reticular formation of the hindbrain, the midbrain, where it has some extensive arbors in the central gray matter of the midbrain. And then it goes into the older parts of the thalamus.
Sadly, not many people are willing to be organ donors. More relevantly, a lot of people aren't in good situations to be organ donors. Okay? As a result, the supply is much lower than the demand. So you have a situation with a high demand, a low supply, and the price went through the roof. That's the positive analysis. Okay? So we can understand pretty intuitively, we don't need this course to understand why the price went up. Okay? It's just the twin powers of demand and supply. But what about the normative question, which is, should this sale be allowed, should eBay have allowed this sale to happen? eBay at $5 million cut it off and then passed the rule saying you can't auction your body parts on eBay. Okay? Should they have done that?
Now we come to a more serious application of the fact that the GCD is a linear combination. We're going to use it to prove the prime factorization theorem, which we've talked about earlier. This is the unique prime factorization theorem. So let's begin by looking at a technical property of primes, which is familiar, but we're going to need to prove it. If you believe in prime factorization, then this lemma, which says that if P divides a product, it divides one or the other of the components of the product, that's an immediate consequence of the prime factorization theorem. But we mustn't prove it that way because we're trying to use this to prove prime factorization.
The reason blockchain might have application is it is a way to finally move money. I don't mean finally like over the centuries. I mean, if I want to move money to Alpha through the US banking system, it might not move for several days. Blockchain is an application that it could have more immediacy. Final settlement. Finance and regulation. We talked a little bit about this when we were talking about the readings, but it's long been part of public policy debates. This is not new. It's not just post-financial crisis. It's not part of like the post-industrial economies of the globe.
I mean, I don't think it's necessarily about the math. I think that the script has a good specific example, and it has a really great big picture. Like, the pitch is awesome. I think that's a really great point to work from. It's just that the connecting piece seems a little bit, like there's not as much connective tissue there. So when I'm reading through this, and I saw Nathan kind of had a similar comment too, I don't quite get how all the specific examples actually relate to that big picture. And for me personally, it was understanding like what exactly, I don't fully understand what a fractal is yet, so I can't make that jump with you to all the applications of fractals.
Talking about axon growth, and I would like to spend most of the time today talking about various kinds of neuroplasticity, how axons respond to damage in the brain, either by regeneration or various kinds of sprouting. So, we were talking about chemicals, effects on growth. This is where we ended last time, and I think this was on your quiz. Caitlin and I wrote very different quizzes, so we're giving quick Caitlin's today. We debated about which one was easier. Well, it's sometimes hard for me to judge what will be easier. So we went by her judgment today.
The last thing I want to talk about is I want to talk about why micro is not just an abstract concept for things like, you might say, oh, this is all pretty funny, and it's like, you know, selling kidneys on eBay and tax cuts for the rich, and why do I care? Okay? Well, you care because literally every decision you make is made through the kind of framework we're going to think about this semester. Okay? Now, different decisions may follow our models more closely and less closely. But there is not an economic decision. Okay? There's not, sorry, let me back up. There's not a decision that people have made the economists haven't tried to model.
The idea of congruence was introduced to the world by Gauss in the early 18th century. You've heard of him before, I think. He's responsible for some work on magnetism also. And it turns out that this idea, after several centuries, remains an active field of application and research. And in particular, in computer science, it's used significantly in crypto, which is what we're going to be leading up to now in this unit. It also plays a role in hashing, which is a key method for managing data in memory. But we are not going to go into that application. Anyway, the definition of congruence is real simple. Congruence is a relation between two numbers, A and B. It's determined by another parameter, n, where n is considered to be greater than 1. All of these, as usual, are integers.
I just highlight this, that it's not a new thing. Blockchain isn't the, we don't have regulation because of blockchain, and we don't necessarily need a new set of regulations. It's because finance is so central to economies, we've been grappling with regulation for a long time. Now, you saw this little framework before, but I restacked it. This is now the stack I think of in terms of financial regulation. Financial stability is first. And while you can't see closely, this is a bank run and a wonderful picture by Dorothea Lange called White Angel Breadline. But this is basically financial stability is probably the first and foremost thing that regulation around finance has been for a couple of centuries. It's how do we make sure that the banks have backing when they take the money in-house, and how do we make sure that we don't have calamitous things.
I think that they're good examples, but what might be an issue here is that it's taking too long to get to the bulk of the video. And this is something that George and I were talking about too, that you have really 3 themes in this video, like cancer cells, nature, and cell phone lines. And I like how you open it with like, what do all these things have in common? But there's honestly so much to explore in each facet that I'm wondering if you should just really focus on one like you had said earlier, just because the thing that I kept thinking about, which is along the lines of Nathan's thinking, and I mentioned it in the comments too, but it really reads like a BuzzFeed article almost at the beginning with like all these examples, and I keep thinking about how awesome of an article it would be with like GIFs showing all these different things.
Now this question has come up a number of times, or had come up a number of times in trying to decide how these growth factors work. So for example, there's a particular, this will come up later in the class, but we can cover it right now. The base at the floor plate of the spinal cord, there are molecules called netrins that are secreted, and they attract the axons of the spinothalamic tract, that is, axons of dorsal horn neurons. So they grow down to the floor plate. But then they cross over, and they go up into the lateral columns on the other side. Well, if netrins had only one effect, they attract these axons, why do they grow past the floor plate at all?
Now what I'm going to do is I'm going to turn and start producer theory, okay, which will not be the example, it'll be the next subject of the course, okay? And we're going to spend a little bit longer on this. So what we're doing so far is saying, look, we introduced the course with supply and demand curves, elasticities, all that, okay? Hint, all that's on the exam too, okay, and all that. Then we said, well, gee, where do supply and demand curves come from? Well, demand curves come from utility maximization, and we talked about where difference curves come from, how the tangencies with the budget constraint leads to demand curve. That's where demand curves come from. We talked about what underlies demand curves is income and substitution effects.
So again, congruence is acting a lot like ordinary equality. If you add equals to equals, you get equals. And of course, the same fact applies to multiplication. If you multiply equals by equals, you get equals. A corollary of this is that if I have two numbers that are congruent modulo n, then if I have any kind of arithmetic formula involving plus and times and minus, and what I want to know is what it's equivalent to modulo n, I can figure that out freely substituting a by a prime or a prime by a. I can replace any number by a number that it's congruent to, and the final congruence result of the formula is going to remain unchanged. So overall, what this shows is that arithmetic modulo n is a lot like ordinary arithmetic.
Financial stability is broader. In essence, it's the thought of, does the financial system lead to instability in the economy? And what is true, again, for probably a couple thousand years, but the research that you can read Ken Rogoff's book. I don't know if any of you have ever read Ken Rogoff's book. It was a wonderful book about the history of crises and economic cycles that came out four to 6 years ago. And I could get you the name of it. But finance adds to and leads to booms and busts. Booms and busts existed well before fiat currency and banking, but there's booms and busts in the cycle. And so financial stability, in essence, is trying to smooth out the cycles, you'd say.
I think in general, and again, this is sort of something that I saw with a lot of scripts, it's a lot of breadth and not enough depth. So lots of examples, but sort of shallowly sitting on top of them. I think this is an opportunity to really challenge your audience and teach them something really substantive that they're not going to get in school. And you can do that through the example. And I think there's a lot that you can cut out, and again, like we've noted them on the annotation so you can see exactly what we're talking about. But if you really rely on showing, not telling, for example, scene 9, where you're describing rivers of the planet, the brain-shaped forest, like you don't even have to say any of those things if you have the images pop up. Like there are lots of fractal patterns in nature, like in rivers, anatomy, the sky, honey, right? Like you've reduced an entire scene down to basically 5 words there.
Well, there is some color representation in the tectum of animals that have good color vision, like the squirrel, for example. But people have not studied color very much in the tectum. It's mostly in the cortex where it's been studied. Okay, so now, what about math expansion? Now, the way that has been studied is very early. We put a little electrode into the eyeball through the sclera. We poke an electrode in and we make a lesion, usually with heat or radio frequency. So let's say we've done that. We've made a hole. Okay, so what happens in the eye? Normally, that would correspond to an area like this. what happens is the axons up here that would normally terminate here, where I'm putting the star, will move. And they will spread into that hole.